So down there here at the bottom, let me scooch myself out of the way real quick. You can see DMX wiring has 3 wires. One is a data positive, one's a data minus, and it's just the same signal, it's just inverted to make it more resistant to, oops, let me move this back over now, to interference. Okay, moving along. So in a conventional light, you've got power, right? Power goes to light, and light turns on, and then we can add a dimmer rack to that. So you got power going into the dimmer rack and then to the light. It's nice. And then we're going to add another device, a light controller. So the light controller talks to the dimmer rack. It sends DMX data to the dimmer rack to tell the light to turn on and off and all that fun stuff. Well, meanwhile, the dimmer rack's supplied with power, and then that, because however the light computer tells it to send the light power, it will adjust the intensity of that power going to it. So let's say you got like an intelligent light, like a moving light or something like that, and you plug it into the dimmer rack. Well, that's not going to work exactly the way you want it to, because if you send dimmed power to something like a moving light, it tends to not only not work, but it can damage it. So we're going to send it data, right? But it still needs power. So a moving light's going to need its own just regular plain Jane wall supply power, and then it's also going to need that data. So now in our little system, the moving light's happy, but the dimmer rack can't be communicated with. So you think like, oh, we'll just split off the data cable, like get a Y cable or something. And then the problem with that is it's going to corrupt the data and it's not going to work well. We need a device called an optosplitter to retransmit that data to those 2 different fixtures or 2 different devices. So the dimmer rack gets its own, and then the moving light gets its own. They both still get power from the mains, and everything's happy. So we can complicate this. We can add a chain of fixtures together. And in this case down here, you see now we have our optosplitter connected to the dimmer rack. The dimmer rack's, you plug in a bunch of different fixtures to it and light them on and off, whatever. And then the optosplitter on the other side, we're connecting to our moving light, and then we got a moving wash light, and then another light, and a fog machine, and a toaster, because why not? And all of these are powered individually, and all of these are in a chain of DMX, because each DMX fixture will have an in and an out. Okay, so maybe the dimmer rack has 24 dimmers in it, so it's controlling channels 1 through 24, and then this first moving light would be 25, right? Okay, but is that next one going to be 26? Not necessarily, because that moving light may need more than one channel to work, because one channel may be just for turning on and off the intensity of the light source, and then channel 2 may be for the pan to tell it to go left and right, and channel 3 may be for the tilt, and then if you have gobos, there may be another channel. So let's say that first light needs 10 channels. So dimmer rack's still 1 through 24, moving lights now 25 through 35, and then this one says 35. Okay, so I made some math problems here. So this would be 36, needs 4 channels, and blah, 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 blah. You have to add that up. So this is what it might look like. 35. So I did this math wrong. I guess I'm an idiot. Oh, well. So let's say your first 24 dimmers, our dimmer numbers are these channels here, or these dimmers here. So 21, 22, 23, 24, maybe like house lights, park hand, Fresnels, whatever. And then you get to 25, which isn't being used by the dimmer rack, but then we'll set that first moving light at channel 25. It would take up 25 through 20, yeah, so 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. No, that's right. God. I don't know what I'm thinking. Anyway, so yeah, then the next available channel would be 35. So then 35, 36, 37, 38 takes up into this moving light wash. And then 39 is your next available channel. And that moving light needs 21 channels. So that goes all the way up to 40. The fog machine gets 2 and the toaster gets 1. So toaster would be channel 42. Now, these numbers are kind of all over the place and confusing. So at the console, at the controller, you can say, I want this to be like a certain number. So let's say The Fresnel wash, we're just going to call that 15, Parcan 16. House lights, we want that to be a memorable number, and we want to combine them. I don't want to sit there and turn on every individual house light, so I'm going to make all house lights channel 20. So console channel, when I'm talking to the lighting computer, that number is 20. Then the moving light, we'll call that one 30. We'll jump up a whole 10 just to space it out, so I know that all my intelligence are in the 30s. So 30, 31, 32, put the fog machine on 33, and then the toaster, because that's weird, we'll just make it 90. So inside that moving light, channel 1, the first channel it talks to may be the dimmer, and then channel 2 may be the pan, and then channel 3 may be the tilt. And then if it has a zoom feature, that could be its own thing. Each one of these data channels will tell the fixture to do something different, so that's why it needs more than just one. So back to our thing. The dimmer rack is going to have an internal terminator. We talked about the terminator a minute ago, but we did not put a terminator after the bread, right? So that's going to potentially cause problems because it could get interference. There could be reflections of data bouncing back, and then things start getting a little bit weird. So you put the terminator at the end, and then everything kind of just works. So it's just important to remember to terminate your runs. So this is, kind of what it looks like when you're done, just to give you a picture of that. Here's another example of it. You've got your controller going to an opto and then connecting to a series of LEDs, maybe connect to a fog machine on one part of the opto. The third leg comes over to talk to the dimmer rack, and then the dimmer rack you plug in your regular conventional fixtures to. There's some new stuff. There's new ways to talk to lights. So DMX has been the standard since like 1985. It's super awesome and robust, but it is limited in what you can do in terms of like how to send it to different things. For example, you need an opto just to spread it out. So there's two protocols that work like computer networking. It's all IP, so Internet Protocol. One is streaming ACN, and ACN stands for Architectural Control Networks, and the other one is ArtNet. And they both kind of work the same. There's a lot of people that like one over the other. I've used both. They both kind of seem the same, and they work fine for smallish networks. I imagine when you get into like huge lighting rigs, it's a whole nother animal. But the neat part about both is that you can run them over just regular network hardware. So you can go down to Walmart, buy a router, and then use that to control your lighting. And in fact, you see these a lot in like holiday light setups. So those guys that do all those crazy Christmas lights I want to say they use ArtNet a lot. They like that one over SACN, but I don't know. They use one of them because, again, you can buy all the gear. So DMX fun facts, this is stuff that you will see on the test. DMX stands for digital multiplex. It was super old. One thing to keep in mind is that each chain, so after an optosplitter, if you have 4 like opto outs, each one of those could have 31 devices on them before you need to plug in another optosplitter to kind of resend all that data. DMX has 512. You may have wondered why it's called 512. DMX has 512 different dimmer channels in one universe. So you can plug in 512 incandescent conventional lights. If you have moving lights that, say, take 50 channels, you could plug in 10 of those, and then you'd have 12 channels left, and you'd run out. Things are happening. So when, it's English. When data is being sent out by the controller, so let's say you want to turn channel 1 on to 50%. So that controller will then send out DMX channel 1 and then 50%. But it divides that 50% into a number that's between 0 and 255. So you get 256, which is a byte of data, and it's 8 bits. So just, you get a value between 0 and 255, but it's translated from 0 to 100% because humans think in terms of 100s. Optosplitters, what does it say? Isolate signal runs by using... So this is kind of a neat thing. The optosplitter isolates it electronically. So instead of having a wire that connects data to that, it has a little LED, and then it has a little receiver, and then the light blinks with the data, highs and lows, and then the receiver receives that. So it's no electrical connection. I just think that's cool.